All right, our topic of exponential functions would not be complete unless we talk about compound interest. And so that's what we're going to do today is look at how your money earns money in a bank account. So if you put in an initial deposit of P dollars, right, and leave it there for T years at a nominal annual interest rate of I, compounded n times a year, then this is the formula that you use to figure out how much you have after a certain amount of time. So we're just going to first of all just go through this example and see how to use that formula. All right, so in this first example, we just we want to find the accumulated amount. That's what A often stands for, is the accumulated amount after 3 years if $1,000 is invested at a nominal interest rate of 4% per year. Okay, so our T is equal to 3 years, right? Our P value, our initial deposit, that's the principal, sometimes referred to as principal. Principal, that's why they're using P. But so the initial deposit is $1,000, and we have an interest rate, our I value, this is our nominal interest rate, is 4%. Now I'm going to write this as a decimal, not as a percent, right? We need in this formula the interest rate has to be written as a decimal, not a percent. Okay, so those are our values. We've got P, we've got I, and we have the T. Now we're varying the value of N. All right, so we're going to look at how this money grows depending on the compounding period. So initially, in part A, we're just looking at interest that's compounded annually, semi-annually, which means 2 times a year, quarterly, which would be 4 times a year, monthly, which would be 12 times a year, daily will be 365 days a year. So we're just going to compare how changing that compounding period, the number of times during the year that it's compounded, how that changes the amount of money that we're going to have at the end of 3 years. All right, and it's just really a matter of just plugging the numbers into the formula and calculating the accumulated amount. So the principal, the P value is 1,000, so we'll replace P with 1,000 in the formula. 1 plus I is the nominal interest rate. So that is the nominal interest rate. It's an annual interest rate. So we have to divide it by the number of time periods, compounding periods within the year. Now in this case, our N is just 1 because we're compounding annually. So we're only compounding once a year, so it's just 1. And then we're going to raise that whole thing in parentheses to N times T. Now again, N is 1, and then T is 3. All right? And then we can just put that into the calculator and see what we get. So I put this into the calculator and I get $1,124.86 if I round it off. All right? So let's do the same thing, only now we're going to compound semi-annually. So that just means twice a year. So N is equal to 2. We're going to use the same formula. So I'm going to put in the $1,000 for P. 1 plus 0.04, and this time our N is 2, right? So we're compounding twice a year, and each half of the year it earns half of that interest rate. So we're going to divide the 4% by 2, and N is equal to 2, and 2, and then T is 3 years still. All right. So plug that into calculator, and I got $1,126.16. All right, so we're just varying the N value. So feel free to pause this at any time. If you feel like you got it, just you can work these out yourself. But so let's go on to quarterly. Quarterly means N is equal to 4. So 4 times a year we're going to compound this. And so we're going to take that $1,000, and this time we're going to divide that interest rate, the nominal interest rate, by 4. and then it's compounded. So this is really this n times t is really just the number of times it's compounded. So it's compounded 4 times a year for 3 years, which means that a compounding gets applied for 12 times over that 3 years. All right, and then it's just really just a matter of putting it into into your calculator, and I got $1,126.83. All right, so you can see the more times we compound it, it's going up. Now, going from annual to semi-annual went up by $2. Now it's really only going up by what, less than 70 cents. So, all right, so let's see what happens if we compound it monthly. Now, monthly, that's 12 times a year, right? So that's the number of compounding periods per year. So again, we're just going to plug this into the formula. 1 plus 0.04. Now we're going to divide it by 12. And then the exponent is going to be 12 times 3. So we're going to compound this thing 36 times over the course of the 3 years. And so put that into the calculator. What did I get? I got $1,127.27. All right. So one more here. Now we're going to compound it daily. All right, so I'm just going to, again, plug the numbers into the formula. This time, it's compounded 365 times a year. So we're going to take the 4%, 0.04, divided by 365. And then we have 365 times 3 will be the number of times it gets compounded over the 3 years. So put that into the calculator, and I got $1,127.49. So it's interesting to see how the way it changed. Really, going from monthly to 365 days a year, the compounding it more and more frequently seems to pay off less and less, right? It looks like we're only going from how many cents is that? About 22 cents in that, going from monthly to 365 days a year. So it'd be interesting what would happen if we compounded it every day, or that is daily. What if we compounded every hour or every minute or every second? How much would that really affect the total amount that we have at the end of 3 years? So that's actually what we're going to look at next. So I will meet you in the next video.